So numerical integration, so numerical methods are not only used to solve equations, they can also be used for differentiation, integration, solving differential equation and many other applications. There are various integrations which can't be found by the formula, okay.
Okay.
So they can only be found by the numerical methods. And sometimes it is not easy to solve differential equations, that time also your numerical method is very helpful, okay. But
Okay.
as it doesn't give the exact value, so we'll apply these numerical methods only when all algebraic and analytic methods are failed, okay. So first of all, the trapezium rule, if you want to find area under the curve, so earlier you were using integration from this point to this point, you can easily calculate the area under any curve, okay.
Okay.
Like we have this example, y equal to 5x minus x square square root. So this is the curve and you need to find its area from 0 to 5. So
Okay.
there is another method like trapezium rule. So you know the area of trapezium?
Oh, yes, sir.
Okay. So if you have a trapezium, so let us say this is our trapezium and this is side A, this is side B. These are two parallel sides and height of this trapezium means the distance between these parallel side is h. So the area will be
Okay.
half h into A plus B. So that is the rule to find area of the trapezium. So this trapezium rule will follow here in numerical integrations, okay. So
Okay.
what we'll do, we'll divide this entire area into some trapeziums, okay.
Okay.
So we can start from, so initial one is your triangle, this one is your triangle, okay, this A. B is your trapezium, isn't it?
Okay.
But you can see it doesn't give you the exact value because this area it is not calculating, this area it is not calculating, this area it is not calculating, okay.
Okay.
So if you are only finding the area of this triangle, so area of this triangle can be find out easily because this is 1, the base is 1, height you can calculate because at x equal to 2, what will be the value of y? Y will be, if you put x as 2, so that will be 10 minus 4, so that is 6 square root, okay. So this
Okay.
length is 6 square root. This length can also be find out. So that will be, if you put x as 4, so that will be 20 minus 16, that is 2. So that is 2, okay.
Okay.
So these areas can be find out.
Yes, sir.
This triangle area and this trapezium area you can easily find out, but it will not give you the exact value, it will give you the approximate value as these areas are missing, okay.
Okay.
But what happens if you take it, if you take more number of trapezium there, so then your accuracy will be increased, okay.
Okay.
Because if you have one trapezium here, so this trapezium, this will be this area, this will give you this area, okay. Like this, its accuracy can be increased if you increase the number of trapeziums, okay.
Okay.
So as we have found the area of triangle and area of trapezium, so you can add them, so you can find out its 6.8990. For greater accuracy, you can use 4 trapezium. If there are 4 trapeziums or 5 trapezium, if you increase the number of trapezium, then your accuracy will be increased, okay.
Okay.
So earlier you can see that it is the area 6.8990, but if you have divided into 4 parts, then its area will be this one.
Okay.
Okay, if you add it, so this will be its entire area. Okay.
Okay.
Okay, now we can have a formula, a general formula. So area is approximately equal to 1 by 2 into strip width. What is strip width? Strip width means you are dividing the entire area, because you are taking it from 0 to 4 or 0 to 5, so you are taking 4 strips. Okay, so
Okay.
these strips will be having the same width, like from 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. If you have one strip there, so this is called as strip width. It is denoted by H. Okay.
Okay.
So this is your strip width into ends plus twice middles. Okay.
Okay.
So strip width we are denoting it by H, ends it is y0 plus yn. Okay, because the minimum value of function from where we are starting, it is at x g x. That means let us say we have this interval from 0 to 5 we are to integrate, then this will be our ends 0 and 5. It is ends in terms of x, but what is the value of y at x equal to 0 and x equal to 5? So that value is to be taken. So that will give you y0 and yn. Okay.
Okay.
So if you have x equal to a and x equal to b, let us say these are our endpoints in terms of x. So you need to calculate endpoints in terms of y. Okay.
Okay.
So that means y1 it will be given at x1, and y2 it will be given at x2. So these are nothing but it is our endpoints. Okay.
Okay.
So these are end values. Got it?
Got it.
And in middle we were having, so that means your area is approximately equal to half h into endpoints, the sum of endpoints, that means y0 plus yn. They are telling it y0 and yn. Okay.
Okay.
So strip width h into ends means y0 plus yn plus twice of the middle. So whatever is the value in middle, so that is twice y1 y2, let us say it is up to yn minus 1. Okay.
So this is the middle height.
Yeah, it is the middle height. These are the middle heights.
Okay.
Okay, and these are end heights. y0 and yn are the end heights. Okay.
Okay.
Understood? Just note down this formula, because we have to use the formula in examples. Is it easy to remember or you find it difficulty?
I think it's fine. So half times strip width time. So I don't get how they've kind of shortened the formula to that half times strip width time.
That is very simple. Yeah, you can see
Oh,
here, if they have divided into 4 strips, so you find this area, this area, this area, this area. So that will be like this one. This is the procedure. Okay. So initially the area is 1 by 2, 1 into 0 plus 2, or you can say initially it was a triangle. So it doesn't have the other side, so we are taking it as a trapezium. So it doesn't have other side, so we'll take it 0. Okay.
okay.
And this is the second trapezium area, this is the third trapezium area, this is fourth trapezium area, this is fifth trapezium area. So if you generalize this formula, if you generalize this, so you can see here in initial one, these are ants. Okay.
Okay.
So this one is same thing, isn't it?
Okay.
This is initial height, this is, and these are ends height. It is first, it is last. Okay.
Okay.
So we can have half, it is height of the strip, so width of the strip, and into ends, these are height of the ends, that is y0 plus yn. Okay.
Okay.
And everywhere you can see it's twice. This is twice, this is also twice. Okay.
Okay.
Because this one is the same thing, this one if you take it, and this one, it is just a twice. Okay.
Okay.
This 6 root, you have 6 root here, 6 root here, so it is also twice,
Oh, okay.
and this one is also twice. So these are intermediate heights. Okay. So
on the graph, there meant to be one more trapezium there.
yeah, you can draw
Like,
any number of trapezium. This is a
so
common.
they've said these are the areas of trapeziums P, Q, R, and S, but there's 5 of them here. But they say only P, Q, R, and S.
1, 2, 3, 4. Yeah, they must take 5 trapezium. In your book, it is only 4 trapeziums are there, but they are 5. Okay.
Are the last 2 trapezium triangles?
Yeah, it is a triangle.
The last 2 are triangles.
First one and the last one is a triangle.
First one and the last one is a triangle. Okay.
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 Got it?
Yes, I got
Now
it.
you can remember this formula.
Okay.
If you forget it, you must remember the working. Okay. Got it?
Okay. So I got like how they've shortened it half times strip width, but why is it twice middles? Because I know it's repeated twice, but isn't the root 6 only repeated once?
Root 6 is here, you can see. Root 6, 1.5. Root 6, 1.5. Okay. This is
Okay.
every term is twice. Every middle height is twice. Okay.
What about the root 6 one, sir? Oh, it's the root 6 plus root 6 it's
Yeah,
given.
it is also twice.
Oh, it's just in one term that's there. Okay.
Okay.
I was thinking there's no root 6 like twice because there's no like different terms of root 6, but there's 2 root 6's in the same term.
Yeah. That is also twice. Okay, you will understand the concepts once you will do questions.
Okay.
So, like this is your curve, and you need to find the area under the curve from A to B. So you can divide it into number of trapeziums, and you can find area separately. Okay.
Okay.
But you can see here there are some area left here. Okay. So if your curve
Okay.
is going down, that means you have left some area, but if your curve is going up, then you are calculating area more than the exact area. Okay.
Okay.
Because here you are calculating more area, excess area you are calculating. So somewhere you
Okay.
are getting it higher area, somewhere you are getting it lower area than the exact value. So if your graph is from up to down, it is going up to down, then you are calculating lesser area. Okay.
Okay.
Here you can say you are calculating lesser area because of this. It is lesser area calculation. Okay.
Okay.
But here you are calculating excess area. Okay.
Okay.
So you need to remember, if your graph is going up to down, so this type of graph will give you lesser area, and if your graph is going up, that will give you excess area. Okay.
Okay.
So that is said too big or too small. When the curve is concave upward, all the tops of the trapezia are above the curve, and the trapezium rule gives an overestimate of the area under the curve. The same thing I told you. Okay.
Okay.
It is a concave upward, so that will give you the excess area. When it is going downward, the trapezia are underneath the curve, the trapezium rules underestimates the area. Now you will get lesser area. If part of the curve is concave upward and part is concave downward, so you can't usually tell if the trapezium rule give an overestimate or an underestimate for the area. If you have both concave upward, concave downward, so you can't say that it is giving you excess area or the lesser area. Okay.
Okay.
Okay, just do example number 14.5.
Okay.
Try to do it by the trapezium rule, then you will understand how it is applied. This
Okay.
is simple integration, you can do it by formula. Okay.
Okay.
But just sketch this curve on Desmos. And these are 4 strips. It will be given to you how many strips you have to take. Okay.
Okay.
That means uh, you are going from 0 to 1. So it is your initial point, 1 is your final point. So this is divided into 4 strips. Okay.
Okay.
So what will be the width of the strip? That will be 1 minus 0 divided by 4. That is 0.25.
Okay.
Isn't it?
Yes, sir.
Okay. And this will be your function. This will be your fx equal to 3 to the power x plus 1. And what is the value of x1? This is your 0, because you are starting from 0. So that is your
Okay.
x1, x2, x3, x4, and this will be your x5. Okay.
Okay.
So these are total 4 strips. So now you need to calculate the end heights. That will be y x1 and y x5. That means y0 and y1. You need to calculate. This will be your end heights.
Okay.
Okay, and in between x2 will be 0.25, that will be 0.5, that will be 0.75, isn't it?
Yes, sir.
So these will be the middle values of x. So you need to calculate y at 0.25, y at 0.5, y at 0.75. Okay.
Okay.
Keep all the values in formula and calculate the area. And also find this area by integration, so that you can analyze how accurate this formula is.
Okay, sir.